This is Honors Pre-Calculus Final Exam Review for 2013. We're looking at number 49, 50, and 51. And these are all going to be done in a very similar way. I think we'll just do them all more or less simultaneously. So one thing we want to be aware of is these words arcsine and arctan, and they mean the same thing as this, which is inverse cosine. So we could rewrite this as inverse sine and inverse tangent. So if we look at number 49 first, and number 49 asks us for the arcsine of 1/2, and so the first thing I'm saying is that that means the same as the inverse sine of 1/2. Another really critical small word here is the word exact. So that means we can't just go inverse sine 1/2 in our calculator, because we need something that is in terms of pi. We need a result that's in terms of pi. So if we want to know inverse sine of 1/2, we want to mentally think of our unit circle. Again, you're not going to be provided a unit circle on the final exam, so you need to know the unit circle. So if we think mentally of the unit circle, and of course you can draw your own at any time. I do this all the time. If I want to solve this problem, I'll just draw the circle first. And then I'll think, where is the sine equal to 1/2? So what inverse sine of 1/2 really means, if we think that's an angle theta, it means that the sine of theta is equal to 1/2. So we're looking for some place where the sine is equal to 1/2, and I know that on the unit circle, the sine is the y-coordinate. So I'm really saying, where's the y-coordinate equal to 1/2 on this diagram? Well, I've got a point here where the y-coordinate is 1/2, because this is the point square root 3 over 2, 1/2. And I've got another point over here where the y-coordinate is 1/2, because that's the point negative square root 3 over 2, 1/2. And the angles of these 2 points are pi over 6 and 5 pi over 6. And the reason that I know that is because I know my unit circle. Now, since there are 2 values on the unit circle where the sine is equal to 1/2, I need to decide which one. And to decide which one, that's why I have domain restrictions on the inverse trig functions. So the domain restriction for inverse sine is negative pi over 2 is less than or equal to x is less than or equal to pi over 2. I usually represent this visually. The domain restriction is from negative pi over 2 down here to positive pi over 2 up here, and everything in between. So that's our restricted domain for sine. And then I can look at my 2 possibilities for inverse sine of 1/2, and I can say, oh, this one is not in the restricted domain, this one is in the restricted domain, so it's this one, pi over 6. We're going to say that the inverse sine of 1/2, is equal to pi over 6. And that's really all we have to say, as long as we understand the restricted domain. So for number, other thing I was going to say about inverse sine, and this applies to inverse tangent as well, is we have to remember that on our unit circle, we're accustomed to calling this pi over 6, pi over 4, pi over 3, and pi over 2. And on your unit circle, you have these points in the 4th quadrant labeled as 11 pi over 6, and 7 pi over 4, and 5 pi over 3. But we're not going to use those values when we're doing inverse sine or inverse tangent. We're going to call these values down here negative pi over 6, negative pi over 4, and negative pi over 3. So it's going to be important to remember that because the domain restriction is from negative pi over 2 to pi over 2, we're going to call these angles down here by their negative value names. That applies to both sine and tangent. So if we look at number 50, then, number 50 asks you for the inverse cosine of square root 2 over 2. So this is just asking us where on the unit circle is the cosine, which is the x-coordinate, equal to square root 2 over 2. So we know our unit circle, so we know this is the point square root 2 over 2, square root 2 over 2. And this is the point negative square root 2 over 2, square root 2 over 2. Is not the point that I want for this. And the other point that I am interested in is this one, which is positive square root 2 over 2, negative square root 2 over 2. So the ones that I'm interested in, because I'm looking for where is the cosine equal to square root 2 over 2, and cosine is the x-coordinate, I'm looking at square root 2 over 2 and square root 2 over 2. Not this one, because the x-coordinate is negative square root 2 over 2. So I'm interested in these two. Now I need to know, out of these two that are my possible solutions, which ones lie on the domain restriction for cosine. So the domain restriction for inverse cosine is negative pi over 2 less than or equal to x less than or equal to pi over 2. So here, and that's completely wrong. The domain restriction is 0 is less than or equal to x is less than or equal to pi over 2. No, pi. Pi. 0 is less than or equal to x is less than or equal to pi. So where that is from 0, which is right here, to pi, which is over here, and from 0 to pi is from here to here. In this domain from here to here, the only solution I have is this one, and that's the angle pi over 4. So I can say that the inverse cosine is of square root 2 over 2. The inverse cosine of square root 2 over 2 is equal to pi over 4. So we want to get straight that the domain restriction for inverse sine is negative pi over 2 to pi over 2. The domain restriction for inverse cosine is 0 to pi, so that's the top half of the circle, and inverse sine gets the right half of the circle. And so let's go on to do number 51. Number 51 asks you for an inverse tangent, and in fact asks you for, it says arctan of 1, arctan of 1, so that's the inverse tangent of 1. And so we can draw a nice unit circle from memory and say, where is the tangent equal to 1? So it will be really helpful if I know my tangents. So I know that my tangents go 0, square root 3 over 3, 1, square root 3, undefined. And then they go negative down this way. And I'll need to know the domain restriction for tangent. Domain restriction for tangent is negative pi over 2 less than or equal to x less than or equal to pi over 2. Same as for sine. So that's from here around to here. And I'm just asking on this interval, where is the tangent equal to 1? I find the tangent is equal to 1 here. That's at pi over 4. So I'm going to say the inverse tangent of 1 is pi over 4. So that's inverse sine, inverse cosine, inverse tangent. We can put all these three pictures, these three nice pictures, we can put them together into a single picture, which I often do, and we'll represent the unit circle. And we can put all of the domain restrictions on the unit circle. So we can say that inverse sine and inverse tangent both occupy the right side of the circle. That's from negative pi over 2 to pi over 2. That's where inverse sine and inverse tangent have their values. And inverse cosine goes from 0 to pi. From 0 to pi. And that's my restricted domain for inverse cosine. So a lot of times students ask me, well, what about poor third quadrant here has no values in it, it's not part of any restricted domain, and that's correct. So when we do the inverse cosine or the inverse sine or inverse tangent of a number, we're never going to get an angle in the third quadrant. We'll never have anything between pi and 3 pi over 2. It will always be between negative pi over 2 and pi over 2, or 0 to pi. And your calculator has those domain restrictions built in, so in your calculator when you press inverse cosine, it will follow these domain restrictions. So that's what we have to say about whatever numbers we just did, 49, 50, and 51.